Good morning, everybody. First of all, thank you for being here today. Thank you to the Poultry Science Association, Dr. Barboot, Dr. Burassa, for inviting us to the symposium. Is this working? Hold on. Okay. So thank you again. And today I'm going to introduce to you the concept of automatic broiler loading at the farm. So throughout the presentation, we'll see a little bit what is the concept of automatic loading and the benefits of using such systems, how the systems evolved during the years and during the decades, and the benefits arising from the use of automation. So first of all, what is automatic loading? It's also known as automatic catching. So it's the process in which the birds are loaded at the farm into the transport modules, but with the use of equipment. So this job has historically been done manually by hand, but the industry has developed systems to automatically carry out these activities. What is seen as the end of the growing process, that is basically the loading of the birds once they reach their target weight, is also, of course, the very first step of meat processing. So it's the link between the growing stage and the processing stage in meat production. The process clearly takes place at the farm, inside the barns. So the birds are collected and placed into transport modules or cages, basing on the country, basing on what is the system used in that area. Once the modules are loaded and full, they're placed back on the trucks that transport the birds to the processing facility. So why is it important talking about automatic loading? One of the first aspect is, of course, the increased productivity and efficiency of the system compared to manual loading, that in turn translate into a higher profitability for these operations. Labor reduction, which has always been one of the main drivers into transitioning toward automation, is one of the main reasons why there is such a higher profitability. Think that a crew carrying out manual loading operation has anywhere between 8 to 10, sometimes 11, 12 catchers, while with the machine, that labor can be reduced down to 3, maximum 4 operators, depending on the type of modules used. So this is, of course, a very important aspect, especially when there are issues with labor availability, and sometimes it's not just availability, but it's also legality of labor and aspects that anyway are connected to that. It's important to talk about load quality. When we talk about load quality, of course, we refer to the typical parameters used to evaluate load quality. So DOAs, broken wings, and bruises. The feedback is that modern machines, when operated by experienced and trained crews, have the same results or better compared to hand catching. So either a reduction of DOAs and reduction of broken wings. Animal welfare has been in the discussion for the last 15, 20 years, becoming always more and more a priority throughout the entire industry. The machines for sure improve this. First of all, the animals stay much calmer inside the house. They are not chased by anybody that is trying to grab them by the feet. And they are always in an upright position. So the chicken is never grabbed by the legs and turned upside down to be placed inside the modules. Operating an equipment to do this operation, of course, improves the working condition for the staff. We all know which a hard our job is to manually catch the chickens is really physically demanding. Also, in relation to what could be, for example, the seasons. During summer is incredibly hot in many areas, or incredibly cold in some other areas of the world. So having an equipment that is operated to carry out that operation improves the condition of the staff, which at this stage we call operators. We don't call them catchers anymore, because now their job is not to catch chickens, but their job is to operate an equipment that does the operation. All these things combined, labor reduction and improved conditions for the staff, of course, allows for an increased pool of potential workers and a lower turnaround of workers in this position, because now the job is easier, and while the the typical catcher anyway falls within a certain type, usually young, male, and fit, because it's a very physically demanding job. Once we work operating machines, that pool is extended basically to everybody. And candidates can come from any background, any age, and they can still operate the machines. So systems started back in the 70s, when the poultry industry became more industrialized, when it went from a more rural production to an industrialized production. The first systems were semi-automated. They were not fully automated as they are now, and they were used to fill the plastic crates used for transport back in the days. So it was a system of conveyor belts that were transferring the birds from inside the house toward the outside, where they were then placed inside the crates. I want to show you a couple of pictures of what the systems look like to give you an idea. So, of course, you understand that to make this work, the birds still had to be caught by hand, placed inside the first belts inside the house, transferred outside, and then is when they were placed inside the crates. There was not such a big reduction on labor needs, small but not as important. The results in terms also of quality were not comparable, honestly, with what was the hand catch. Also, if you look at the system, you understand how this could, anyway, is a fairly complicated system with a long setup time, a long takedown time. Transport from farm to farm was not easy, and even moving from house to house was a time-consuming operation, because the system had to be disassembled and reassembled on the next house. So in the 90s, there's been the very big evolution in terms of automatic machines, and it's when the industry has adopted the use of modules to transport the birds. So once there's been that transition, that the module could be filled directly inside the barn, machines have evolved towards self-propelled machines that were carrying out the whole operation inside the barn. So collection of the birds and placing the birds inside the modules. This allowed for a very important reduction of the numbers of the operators needed for the operation and improved productivity. So here you can see some pictures of what were the machines in late 90s, early 2000s. So concept of frontal harvest, fully automated, so nobody's touching the birds to enter the machine. And the machine was basically placing the birds directly into the container. Machines were smaller. First machines had a smaller capacity. We're talking about machines with a harvesting head of 2.5 meters, about 8 feet. They kept on growing. If you look today, we are about 30 feet wide and with a higher capacity. The second big step was in the last 10, 12 years. So the industry needed machines able to provide a higher output to meet the needs for the processing facilities. But the evolution was not only toward capacity, but keeping as a priorities also load quality, animal welfare, and biosecurity. So these became the three main aspects that have been always kept in consideration during the last evolution of the machines. So this has been accomplished, for example, changing a little bit the idea, for example, making machines going wider, so increasing the volumes of the birds that were collected, and at the same time reducing all the speeds of the machine itself. So the idea was higher volume, lower speeds, we improve quality. Another system it was, and we'll take a look at that in a few minutes, is a scale installed on the machine that is reading how much weight is going on each compartment of the modules. Animal welfare, there have been adopted different technical solutions to allow and facilitate the birds to always stand on their feet, for example, and to avoid sudden movements within the machine where they would be flapping their wings and create damage to their wings. And biosecurity, it was another very important aspect that we might take a look later about that. We have a specific slide for that. So here you can see the modern machines, how they look like. As you see, they are much wider, much longer. Being longer, it's been possible to reduce the inclination of the belts. And that has been a very big step to improve the load quality. As you see today, machines are about 30 feet wide. Machines can be produced with any width. That's more or less the biggest available on the market as we speak. And this is also linked to the fact that farms are gone always bigger and bigger. It's also in the US now, it's fairly common to find those mega houses that are 66 feet wide by 600 feet long. So those houses are, of course, very easy to be caught with the machines. So I'm going to just go through a little bit the main concepts, how it works, and then I'm going to show you a short video that I hope is going to explain to you everything about it. If you have any question, please feel free anytime to stop me and ask about that. So during loading operation, we recognize three main steps. The first is what is called the harvesting phase, the collection of the birds. So the machine, as said, is self-propelled. It moves on rubber tracks. It's placed inside the barn, at the entrance of the barn, and the harvesting head is opened in front of the machine and lower on the ground for the collection of the birds. So at this point, the operator on the machine just starts the process, and the machine starts moving the belts and crawling toward the chickens. The chickens are collected from the front belts and developed into transversal belt, then bring them toward the center of the machine into the main channel. So the second stage is what is commonly referred to as the caging phase. So the birds are transferred along the length of the machine until they reach the last section, that is the caging belt. The caging belt is able to move left and right, up and down, and to be placed directly as close as possible to each single compartment of the modules or the cages. So the machine deposits the birds inside the compartment, and whenever that compartment reaches the target weight that has been preset at beginning of operations, the machine automatically stops. So nothing is moving on the machine. This gives time to the operator to move to the next compartment, and then it's the operator that again is restarting the machine. The third component on the machine that is an integral part of the machine is the carousel. So the machine pulls inside, behind itself, a small trailer where there is a carousel installed over the trailer. So this trailer brings in 2 or 3 modules, depending on the configuration. And this module, basically, the operator puts the first empty module in loading position and starts filling it up. Once it's full, it just simply rotates the carousel, making that full module available for the forklift to be taken back out to the truck, and bringing in loading position a second empty module to keep the process always continuous. It's important to talk about this part because that's where the machine is actually reading the weight. So the machine is reading the live weight as it's deposited inside each compartment of the module. And the carousel is constantly communicating with the machine to when basically stop the belts. So this is a little bit the main concept. I'd like to show you a video now, if it's okay, and hopefully that will clear any additional question. So hope that helped a little bit in understanding everything I was explaining. I understand sometimes it's not easy to picture what is actually the machine doing. Of course, all the operations that I mentioned, they all occur at the same time, simultaneously. So the machine is constantly collecting birds, placing them into the modules. It's, of course, a continuous process, and it stops only when it reaches the target weight each compartment. So when evaluating automatic loading systems, what are the aspects to always be taken in consideration? One of the most important, and usually is the first one to be addressed, is the loading capacity. So modern machines can reach capacity up to 26 tons per hour, sometimes 28. That number changes based on the type of modules that is used. of course. So, but in optimal conditions, that's a number that is reachable with modern machines. And we talk about tons per hour, not chickens per hour, because for the machine it doesn't make a difference if it's loading a small bird or a big bird. It works by weight. So the machine is loading a certain amount of live weight per hour. Load quality, because as we mentioned, numbers are equal or better than end catching, but another important aspect regarding load quality is how the quality stays constant throughout the shift and throughout time. Manual catchers, usually quality and times are much better during the first hours of the day, during the first hours of their shift, but then there is a decline in load quality because people get tired. It's normal. It's human. It's what we're made of. So we don't see that happening with the machines. Machines have the same quality throughout the entire operation. And working by weight, the machines always load the right amount of live weight on the transport trucks, making all that area more efficient, because the machine do not overload trucks and do not underload trucks. While when hand catchers, that number is always a question mark, and nobody knows that number until the truck is actually at the plant. Loading the right amount of birds, the right amount of live weight, is crucial to have lower DOAs. Is what is actually bringing the DOAs down, because the density within the modules is always respected. Big aspect is, of course, the training of the operators. There is a learning curve when the system is integrated into a certain process. Operators training sometimes might take, it goes from few days to sometimes few weeks. It changes depending on external factors. Anyway, it's normal to see that it takes, again, a couple of weeks to get the crews to the results that can be expected with the use of the machine. From the logistics standpoint, it's important to think that now it's a machine that has been moved from farm to farm, and it's not just a crew of people. So it's important to try to schedule both placing of the birds and catching, loading, in a way that minimizes the movements of the machine and optimizes how the machine is moved from farm to farm. And of course, maintenance, because like any other piece of equipment, needs maintenance. Most of the times, there is already an organization in place, especially when we talk about integrators. And it's just important to include these systems in that type of organization, carrying out preventive maintenance and having an organization able to basically do preventive maintenance and repairs as needed. The aspects that might determine, for example, configuration of the machine is, and also it's important to understand what the machine can do, how it can adapt to a certain situation. So first of all, it's important to understand the type of modules, because basing on the type of modules, the machine may have different settings or completely a different version. If we compare the modules used around the world, in Europe, Canada, and we compare them with the cages used to the US, in the US to transport chickens, it's two completely different versions of the machine. The size of the birds is important because the machine, it is true that they're able to load 3.5-pound birds, and there is experience every day with 10-pound birds, 10.5-pound birds. But the machine is set differently, so it's important to understand that for a certain weight, the machine needs to be set in with certain parameters. Litter condition is another aspect because, especially between US, again, and the rest of the world, there's a big difference on litter condition. The rest of the world, there's concrete floors. The litter is never more than 2 inches, maybe 3 inches top. In the US, there are deeper litters, up to sometimes 10, 12, 15 inches. And they're more uneven. So it's important to make sure that the machine is able to handle different situations and adapt to different situations also in that regard. And then houses specs, because especially older houses that were built before there was the idea of automatic loading, before there was the idea of a machine moving inside the house. So they may still have columns inside that limit the spaces available. So it's important to always keep that in mind to make sure that the machines have the correct configuration to be able to work in those conditions. I wanted just a few words about biosecurity. We all know that biosecurity changes from not even country to country, but even from almost county to county, I would say sometimes. Really depends on the situation and which time of the year. So equipment is designed to follow worldwide guidelines in terms of cleanability and biosecurity. So the first concept is, let's design something that does not collect dirt. Second point is, if it collects dirt, let's make sure that the machine can drop it as soon as possible and it does not accumulate. And everything must be accessible with high pressure washer. And it needs to have a very good drainage so that all the contaminated water from the washing basically does not pile up on the machine, does not accumulate from the machine, but it dries out as quick as possible. And then one of the biggest and most important aspects is the materials. In modern equipment, any part of the machine that is in touch with the birds or the litter is made out of stainless steel or rubber compounds that are easily washable and disinfectable. And talking about biosecurity, as maybe you noticed that on the video, working with a carousel and the modules always being placed over the carousel really allows for an improved biosecurity also at the plant, because the modules are never in touch with the litter. They are not placed on the litter, but they're placed over the machine itself. The last point is data collection. As of today, already machines basically can tell us how much live weight has been loaded in each compartment, at what time of the day, how long it took, give us all kinds of information. Next step is to be able to see those informations from remote, live, from the live oil manager office. Let's say, let's check crew 3, let's see how it's doing. And there are projects to always keep on collecting more and more data and information, because all this data can be a really important tool for the industry to improve efficiency on this part of the process. Thank you so much.